Hi, Larry at Hagemeister Enterprises here. We're going to talk about 42MT starter today and 39MT starter. This video is going to coincide with why is my solenoid clicking on our previous video, and do some more explaining on how mechanically this works. This particular starter has got about 6,000 hours on it. It's a 12 volt 42MT Delco. It is in a Caterpillar track tractor, which has a starter on each side of the engine, and this is one of those starters. The other starter was just like this one. So what I want to explain to you is how the clicking issue on this starter was 100% mechanical problem. It was nothing electrical, it was all mechanical. And the customer brought it in, and again, about 6,000 hours. They were doing preventative maintenance and wanted us to look at this and see what we could help them with. So I want to explain to you how this works. So these starters here have a secondary solenoid, a small solenoid here, which is hooked to the ignition of the tractor, and this solenoid drives this bigger solenoid because of the higher amperage draw. And we're going to do that amperage draw measurement on this solenoid before we're done, and we're going to talk about that in comparison to the 39MT. Now, this starter was clicking in the tractor, and again, electrical energy that the starter gets turns it into mechanical energy to turn the engine. When I say that this is 100% mechanical problem, that's exactly what I mean. When it's in this tractor for that 6,000 hours, look at the kind of war it's done on this shaft. Up and down. The bushings are all gone. Look at that movement. And this starter drive comes straight out. There's no twisting of it. It's straight out. There's no helical into the flywheel. The only helical it gets is right here, built into the starter drive, and that's resisting my push. That's resisting me right now. So let's just do a spin test on it and see how it sounds anyway. Doesn't seem to have any clicking issues at all, but as I pointed out here, again, this is why it's clicking, because this has been blown out of the dirt and dust, but the 6,000 hours that this is riding in the tractor, bouncing across the field, that's what it does to the bushings. That's what it does to these shafts. So nothing is lined up. It's going in there and not correctly because of all the wear. And this here needs to compress in when it hits the flywheel, but right now I can't push it. It's stuck. It's stuck right there. So there it broke loose. So there's some of your click problems right there. So this is a starter drive here out of the 42MT, and this is just a regular old Delco starter, which I want to explain the difference here. So this is a straight spline. As you can see, the splines here are completely straight. There's no helical or twist in that because the armature shaft is completely straight. So here is the helical that the starter gets is right here. Now this is a pretty new starter drive, and it's got lots of free indexing to help it go in. But once that gets contaminated with dust and debris, it starts restricting. So now we have a mechanical click on the starter, not electrical. That needs to be known. So it's a mechanical problem, not electrical. So this is a typical Delco starter here. Now its compression spring is right here, and the helical is the shaft right there. This shaft is helical. It's twisted. So when the starter starts to engage into the flywheel, it gives us a twist just like that to get itself into the flywheel. That's essentially the difference between this style of starter drive and that one. So I've got my test cables hooked up here to just the solenoid. I'm not going to do a motor test. I just want to show you an amp draw on this solenoid when we engage the solenoid to see how many amps it's drawing. And that's the reason why we need this relay solenoid. So if we take a look up here, this upper scale is on 0, and we're going to see how high it goes when we just do an amp draw on the solenoid. About 60 amps. Our voltage is holding about 11, and it's about 60 amps. As it heats up, it's diminishing. So this is a 12 volt 39 MT starter. It's a later style as far as technology is concerned and the design. It's actually a gear reduction starter. So the armature shaft comes in here to some planetary gears, and then that energizes this main shaft and causes the starter to turn. And again, this one also has a start relay on it mounted up here, and we'll talk about that amp draw. Now here's the benefit of this starter over the 42 MT. You can notice the starter drive is all exposed and it's recessed. It's recessed setting in a bearing. There's not a bushing in there. There's not a shaft out here like the 42. So the contaminants really doesn't bother it because all this is recessed. So when it's in the machine or truck or tractor, whatever it may be, this really, the bouncing is really not going to wear because it's in a hardened ball bearing, not a bushing. That's the benefit of these style of starters compared to the straight shaft. Now, this one here is the same type of gear. I'm going to pull it out, and you're going to see that helical? Now that's twisting just like the Delco over there. That's how it's getting its twist into the flywheel, just like that. And then underneath this gear is a spring that helps it compress when it hits the face of the flywheel to get it engaged into the engine. But again, it just makes a nice twist right there. So let's do a bench test on this one. Seems to be working fine. These 39 MTs have an immense amount of solenoid draw to draw in the starter drive. The 42 MT had about 60 amps, and we're going to see what this has. You can see with this relay solenoid here, they've got some pretty big wires coming off here going to our motor. Pretty big in comparison, and only being that short. So we're going to just engage the solenoid like we did in the other one and see what kind of amp draw it has. Look at that, 120 amps. Even tries to turn the starter because there's so much current running through it. We've actually had customers take these off because they didn't know any better, I guess, and try to use their existing one, and Delco doesn't want you doing that. They want this solenoid used because of that 120 amps. Just to sum it up today, this starter is, again, later style technology, gear reduction, 39 MT. It weighs about 25 pounds less than the 42 MT, so that's an advantage. And the nose cone clocks just like the other one for different applications. Not that the other one is bad, it's just a difference in technology. We've went for years and years and years with the other starter, which is fine, but this is just something with a newer style, and most things today are gear reduction starters. Thank you for watching.